What's good, YouTube? I'm Dewan, and we're back with part 5 of our Packet Tracer RIP series. And in part 5, what we'll be covering is Trunks and Inter-Vlan routing, 802.1 encapsulation specifically. Now, we're almost done. We got a few more videos. The next video will be over DHCP, and then after that, we'll be configuring RIP, and then we'll configure ACLs, and then we'll do some troubleshooting and testing, so you guys can pretty much have a full in-depth understanding of how to configure a RIP network from the ground up. And then the next series won't have to be so long because things like SSH, securing and hardening your devices will already be covered in this series. So the next series of OSPF videos won't be so redundant because you will already have a full understanding of how to harden your routers and how to harden your switches, and then also the basis of configuring your devices. So all we will have to do is dive in OSPF and knock that out. But let's get this thing rolling. But before we get this thing rolling, my man Potency Records, he called me out on the last video because I guess when we went into the switch and configured the VLANs, I actually put parking lot rather than parking lot VLAN. So let's do a show VLAN brief. And yep, I forgot the R in parking lot VLAN. So let's go ahead and fix this. That's the thing about doing these videos. You got a million eyes that can see what you do. You got to make sure you get it right, because one of the things I hate doing is giving people the wrong information or, you know, messing something up that kind of throws people off. That's one of the reasons I take so long on these videos, because I want to give you guys the best and most accurate information to help you all be successful. I mean, because that's very important to me. Now, we got that straight. I'm going to go ahead and save that config. Now what we need to do is talk about 802.1 trunks. So there's two types of trunks. There's 802.1 trunks, which are, there's 802.1Q trunks, which are IEEE standard. And so even Cisco kind of says, hey, 802.1 trunks are better. And then you have, what is it, the inner switch link, which is the Cisco protocol for trunks. Now, with the 802.1 trunks, what it does is encapsulates your frame. And in that frame, you got your destination and your source portion of your headers. And then what it does is it sticks a 4-byte tag in between your frame to say, hey, tag this frame as a part of VLAN 20 or VLAN 10. So when you're communicating between switches, when it goes over a trunk basically takes multiple VLANs and span them to either a switch or a router. So with this here being a trunk to your router, all the VLANs, VLAN 10, 20, and 30 will go up this trunk, but how will your router know which VLAN to be a default gateway for? That's where 802.1 tags or encapsulation comes in. So what we're going to do is configure a trunk on the switch, and then we're going to go and set up our sub interfaces on our router, and that's Inter-Vlan routing. Now there's two types of Inter-Vlan routing. You got per interface VLAN routing, and then you have router on the stick Inter-Vlan routing. What we're creating here is going to be routing on the stick. If we were doing the per interface VLAN, we would have to have multiple interfaces, and each VLAN would have to have its own interface connection to that router. That's expensive and not even necessary when you can just create a trunk, create sub interfaces, and boom, there you go. So let's go in here to our switch. Our connection to R1 is going to be IP interface brief, and I believe it's going to be gigabit 01. So if we're going here and do a config T, what you want to do is go into your gigabit 01 if that's what you have it connected to. That's what we have in this lab. And what you want to do is tell the switch port, in other words, tell it to be a switch port. Then you want to do switch port, trunk, encapsulation. Well, I guess you can't do it on here, but in a normal network, you would do switch port, trunk, encapsulation, 802.1Q, letting it know. But just for packet tracer purposes, what you would do is switch port, mode, trunk, and that's telling the switch port to operate in trunking mode rather than access mode. And it's going to stay trunking the whole time we use it. And now we're going to tell it no shut to bring it up. and we'll do a write mem or copy run start. I know that's what you guys use. Write mem is also another way you can save your configs, but for Cisco purposes, you need to do copy run start. In other words, copy your running configuration to your starter configuration. Boom, got that all good to go. If we do a show IP interface brief, you see gigabit 01 is up. If we do a show interface trunk, you can see that we're operating in trunking mode, and our encapsulation is 802.1q. Our status is trunking, and our native VLAN is 1. Now, we could change our native VLAN to something else, but we'll leave it as 1. Native VLAN 1 is default. You can leave it as that, but basically just know that your native VLANs need to match on both sides of your trunk, and that your management should never be your native VLAN. Cool. So we got that all squared away. Now, as you can see, all of our VLANs are allowed to travel down our trunk, and that's okay. We don't need to filter anything. We'll just let everything travel down this trunk, and they're good to go. Now we go up to R1, and we need to configure some sub interfaces. Now, when they say configure sub interfaces, that's going to be your default gateway for each of your VLANs. Remember, your VLAN is a broadcast domain, subnet, segment of your network, doesn't matter. Your sub interfaces will be your default gateway for your networks, and we'll set that up now. So right now, let's go in here to our password is going to be console, enable Cisco to get in privileged exec mode, and now we need to go into global configuration mode with config T. First thing we need to do is go into gigabit 00, and we need, if I can type, gigabit 00, and then we need to bring this up. So do a no shut, and now we bring that up, and then we need to go back into gigabit 00, and let's go .10. This creates a sub interface. You don't put on your main interface, you do not put an IP address, you just bring it up, and then you start creating sub interfaces by doing the interface and then the gigabit/0 dot whatever your VLAN number is. That's the way I usually do it. So, but you can put that number whatever you want it to be. I usually put it as the VLAN number so I will know. So this is gigabit 00/0.10, and then we need to do encapsulation .1q, and that means what VLAN is going on this sub interface. We're going to go 10, and now you put your IP address, and the IP address is going to be 192.168.10.1. This is going to be the default gateway for VLAN 10, and then you can also put a description, and we'll put default gateway VLAN 10. For each sub interface, if you want to put a description there, you can. Now we have VLAN 10 created. We need to do the same for VLAN 20. So let's go in here to interface gigabit 0.20. I did it right from that sub interface. I went right into the next sub interface. You can exit out if you want, but you don't have to. And so we'll do encapsulation .1q and then 20, and then IP address 192.168.20.1 with the encapsulation telling it, okay, you're the default gateway for VLAN 20. Boom. Now we need to go into gigabit 0/0.30. And for this one, encapsulation, get in the habit of .1q 30, and then IP address 192.168.30.1, and then it's a /24, meaning there's 254 available hosts in that subnet range. Now that's all configured. Now if we do a show run, let's see if this works. Gigabit 00. Nope, you can't do it. So let's just do a show run, and then we'll go down to our sub interfaces. And as you can see, our sub interfaces are created. They're up and working. Now, a way to test it. So in the last video, we added an IP address. This is 10, and I believe this is .11. All right, so if we go here, first thing we want to do is IP config to see the IP address of this system, and then also to see the default gateway that's assigned to this system. I never set one up, so I'll go in here and set this up. In the next video, we're going to set up DHCP. In other words, to automatically assign IP addresses to these devices. But until then, I'm just going to manually set it up so we can just test it out and see if it works. So that's good to go. Now we'll go back in here and do this again. And then we'll ping the default gateway 192.168.10.1. Boom. That's good. And now let's see if I can ping 192.10.11. I should be able to ping that because they're in the same broadcast domain. Remember, broadcast domains do not extend past routers, but routers connect networks. In other words, if you have the VLAN 10 and VLAN 20, the only way they can talk is with a router. And that's what we just did. Set up sub interfaces, which is a router on a stick, in order for our VLANs on switch SW1, all the VLANs that's on that switch to communicate. Now, in order for these VLANs here to communicate with this network here, we're going to have to set up the same thing over here with sub interfaces for these VLANs here. Now the VLAN numbers on here are 10, 20, and 30, but they have nothing to do with over here because remember, routers cut off or separate broadcast domains. They do not extend. VLANs will not extend past your router. So that's something to keep in mind. And the next thing we need to do is set up our IP address on SW1 for VLAN 10 for management purposes. So if we go to here, as you can see, the management VLAN, let's do a show VLAN brief. The management VLAN for this network is going to be VLAN 30. So every switch, even if it's a layer 2 switch, has a layer 3 or an IP address, has an IP address that you assign to it for management. And in order to access that device with that IP address, you also have to set up a default gateway on that switch in order to access it outside of the broadcast domain that it's in. Remember, routers connect networks. So in other words, in order for you to connect to another network or another subnet, you need a router to do that. And if your device does not have a default gateway configured, it will not be able to talk outside of its broadcast domain. So what we're going to do is go in here to config T, and then we're going to go interface VLAN 30 because that's the management VLAN, and then we're going to get its IP address 192.168.30.2. Does it help if I put IP address first? 192.168.30.2, and then we'll put the subnet mask of /24, and now we have that configured. And make sure there's a no shut. Now the next thing we need to do is set up the default gateway on this device so we can access it. So that'll be IP default gateway, and it has to be in the same broadcast domain as the IP address on the device. And now it's configured. So if we go to this device and ping 192.168.30.1, it should come back and let us know we good. Now it came back, we're good. Let's go show IP interface brief, type exclude down. There we go. Now that you can see this a lot clearer. So we have ports 1, 2, 3, and 4, or 01, 02, 03, and 04 up, gigabit 01 up, and then VLAN 30 is up with an IP address. So that's good to go. So .10 and .11. I should be able to ping .11. And if I can't ping, you know why I can't ping? See, this is a troubleshooting tip just for you guys. And it's good that we ran into this. Remember I said that default gateways connect networks. Now the reason why I can't connect to what PC is that? PC3, which is here. The reason why I can't connect to this PC3 right here is because it does not have a default gateway configured. Remember, default gateways need to be configured in order for you to be accessed from outside of your network, and then also for you to access outside of your network. So since I'm on VLAN 30 on SW1, I couldn't access PC3 because it didn't have a default gateway set up. So I'm probably pinging it. The pings are getting there, but it's not able to send anything back. So we'll go in here and I'll show you guys. No default gateway configured, as you can see. And that's why SW1 was not receiving any pings. But once I set this up, it'll be 192.168.10.1. And if I go back to SW1, and as you can see, I was pinging before and I didn't receive anything back. They were just going and not coming back. So if I do it again, 192.168.10.11, boom. Default gateway configured, everything set up, good to go. Now let's do a copy run and start. Start copy running config to the startup config. And then let's do the same thing on R1. Since we have this all configured, copy. All right, so that's good. Now, the last thing I want to show you all is, now that we have that configured, now if we do a show IP route, you'll see these routes that are configured for the sub interfaces. And as you can see, the C means they're connected, means they're actually connected to the device, they're inside the device, and the L means locally connected. So whenever you see the C and the L, that means they're locally configured in the device. I think that's pretty much it. I'm going to go over here and do the same thing to R2 and SW2. If you guys got any questions, feel free to hit the comment section below. I thank you all for viewing. Peace.